So I've been asked to do a video about the sliding fiddle yard that I've designed for my Essex brick layout. A bit of history. In lockdown I thought I'd design a little layout. I wanted it cheap. I wasn't going mad and buying all expensive stuff. So I bought a box of FlexiTrack, and I do a lot of 3D printing, so I thought I'd 3D print as much as I could. Turnouts, turntables, brackets, and also I was only going to use what I had in the garage, apart from the electronics which I had to order from China. So I decided this was the layout, and it's being fed, I think it's 16 tracks here that come from the behind the buildings. There's buildings, this is the back scene, and these are the tracks that feed it. So to feed it, I decided sliding fiddle yard. Why not? How hard can that be? Well, quite a bit hard actually. But anyway, so piece of OSB board, and I managed to get 32 stabling tracks on there. Now they are only short. A, I've not got a lot of room in the garage, and B, it's a small layout, so it's going to be small shunting trains just dropping off wagons or just riding round. So I think I can get like 3 wagons and a small loco in here stabled up, which is absolutely fine for what I intended. So this was the layout, plastered over and sort of the baseboard complete. These little plugs here are where I know I can drill through, because all the wiring now is now covered in air dry clay. So I'm not going to do hit or miss if I can drill through, because if I hit a wire I'm up the creek. But say these little plugs I know will go straight through. And this is the start of the fiddle yard. Now these are infrared detectors. I did toy with the idea of a laser going straight across, detectors coming up, but I just opted for a very basic, and I thought was a good idea. So we got the transmitter, one of these is, and one's a receiver, don't ask me. And if you put them at 45-degree angles, it should capture the vehicle or the loco coming across, and it doesn't spot the gaps, because you can get false reading. If you go directly across, which would have been easier, you can spot gaps between the wheels and stuff. So I read somewhere 45 degrees and a quick 3D print, and this is what I come up with. Now bearing in mind that all my locos have stay alive capacitors in them, and very good ones as well, because you see there's a lot of plastic. All these turntables are plastic, crossovers here, so I do need decent stay alives. That was just a picture of this. Is sorry, there's 2 wagons there and a small loco, and I can get another wagon on there. One of these wagons is the motor wagon, which got all the drive gear in. I think I've made a video on it anyway. And the other one's got the decoder and stay alive, and the lead weights to keep it all down. But as you can see, in theory, if the loco is anywhere near this beam, the sliding fiddle yard won't move. There's a close-up of the infrared detectors. Well, you'll see in a bit. All I've done was got cheap boards, took the detectors, the LEDs off the top, and just rewired them. 32 of them, so it took a little while. Going along the sliding fiddle yard, this is the right hand side. It's just a quick box, so I wanted something to mount the switches. I'm not sure what I'm going to do with it. We've got 12 volt power to drive the stepper motors, and we've got 5 volt logic that drives all the Arduinos and stuff like that, all gear like that. And this one here is just a reset, so I can reset the fiddle yard, because it's all based on an end stop. So all my track positions based on an end stop. So if it goes out of kilter, the only one I've got to adjust is the end stop, which will bring it all back, because these are all set up now, in theory anyway. So because I've DIY plugged it all these plugs on here and on the main board are different in one way. So I can't plug my 12 volt in my 5 volt or my track in my 5 volt and blow everything up. In theory, we'll see. That's one of the NEMA 17 stepper motors there. I think we'll have a better view after that. This is the underneath of it. So these were 3D printed plugs, just the banana type plugs, bulletproof, pull in, push out. You know, they just work. It's not very refined, but they work. This relay here is for my track polarity, because on the top you've got 32 tracks and 16 out. Some of them will be reversed, if you get what I mean. They'll go out on one track and they'll come in on a reversed polarity. So this is the logic that whatever tracker is active, when the loco comes in, it comes in on the same polarity as the track, because the track's loop round. I think you get me meaning. The only important thing here is this resistor here on the infrared detectors actually controls the whole lot. If this isn't here, none of these IR detectors work. So I should protect that a little bit better, I think. This plug here goes to the end stop, which is another important thing. Without them, not a lot works. So these are the infrared detectors. I just disassembled these. The LEDs come attached. Just took them off, put some wires back up. This is my bus. So I've got what have we got here? We've got my neg, my 5 volts, my logic from my infrared detectors, and this is track feed. So, and I looked in, it's a bit dodgy, some of them connections on there. I'll have to get in there with my soldering iron and redo some of these. That's what happens when you're in the garage upside down on a rush job. So this is the board upside down. So as you can see, we've got two NEMA 17 motors, one on this side and one on this side, and I just went on the principle 3D printers. It just moves it up and down and it's going to be spot on. I did get the accuracy down to 80 steps per millimetre, so I can dial in each millimetre to 80 different positions, so that's well good enough for what I need. The actual board runs on two draw runners. I don't know if you know, they're metal type ones with the ball bearings in, and this is all what I had to hand in the garage. So this is OSB board. I had a sheet of that tucked away, bit of 2B1. These brackets are all obviously 3D printed. Obviously had some spare purple, that's why they're in purple. The NEMA 17 brackets, same again. And if you look here, this is the NEMA 17s move backwards and forwards, they're in tandem, and this just attaches to the board and moves it backwards and forwards. Now this end stop, I've redesigned it so it's reverse round, so the end stop electrics is on the board. I think we might see that a bit later. And these are just the runners, makeshift because I wasn't sure how it was working, and they're still on there. It's a bit of the underside. So we've got the end stop, just two wires wired into the Arduino, and this one here is my RS485 bus. I'm working on JMRI, CMRI. I think I'll have to do another video after with a sketch and show you my JMRI and CMRI, how it runs it. But basically it's a bus that goes round and loops round, comes back, goes off to the main board. I'll do another video, I think, because that needs a bit of explaining. NEMA 17 motors, I think these come off my old printer, or I bought a job lot from China. Work perfectly. They're cheap and they're quite powerful. I did put 20 kilos of weight on the top and it moved it absolutely fine. Slid up and down, no problems at all. These are my makeshift bearings. Now I have redesigned them. I've got to swap them to give me some movement up and down, some adjustment basically, because the board was stood on its end in the garage for 2 years and that's not kind to it. So there is a slight misalignment now, but as you can see that this is quite a small gap, but some of these are big gaps, and it's only a bit of board, so it's going to sag, so I need some more adjustment there. Yeah, there's a bit of close up. I did 3D print these and I didn't have anything, the bearings were just sitting on the plastic. Now fine if they're just running up and down, but when you clunk them trying to put the fiddle yard into the conduit, if you bang them it knocks them off. So I just drilled a hole and put a bit of bar in to reinforce it. Oh, by the way, it all runs on this piece of electrical conduit I found in the garage. 3D printed some brackets, hold the conduit up, and that is my track. That's what the whole lot runs along, that and 2 draw runners on the reverse side. A bit of a close up on the the belt tensioner come drive. So I have found that if you're mounting anything plastic on, rather than 2 big screws, I think I've got 6 little screws. They're far better to have 6 little screws than 2 big screws, especially this board is only 12mm 1/2 inch thick. So, and it's just the basic principle of 3D print. Yeah, one end is tied, the other end tied, and this is just a guide roller. I think I had these spares on some of the spare kits at my printer. Just a different picture. I don't know if there's anything exciting on there. So this belt, it's only the same size as what you get on a basic Ender 3 or something like that. You can see the length of it. Now this here holds this track. This is a track underneath my layout which runs my canal boats. So on this track runs small 040 locos with a bit of weight on. They run around here, and above it I'll have a canal boat with a magnet on being pulled along, and this is what goes through and out. I don't know if you've probably seen the videos on the actual layout. There's a canal scene, and this is where they go round. I don't know if we've got any other pictures, but there's a couple of turnouts, so we've got plenty of options to run boats round. This here is just holding the bracket up, holding the deck up, and I thought I'd put some as a bus going round. If I need wiring to go round, I've already got the brackets inbuilt. Bit of strength. It looked like that one broken there, doesn't it? Or bent. It was a fiddly job though, very fiddly. It's like everything. Once you design this, you think, should have done it another way. But there we go. Right, this is how I control the stepper motors. We'll start off with these 2 on the right there. They're the RS485 bus controllers. They're very cheap, 30p each. So cheap. And you have a line coming in, and you must loop it, so a line coming in, line going out, and then back again. And all you do is these are connected up. 3 wires is all you need. I think one goes on pin 2, receive and transmit. and they're so easy on the bus, and the whole layout is run on this bus. But I think I might do another video on that and how I run it. These are the stepper drivers, very basic A4 988s. They're not quite ones, but then I don't need it because it's not making a load of noise. So it's just a bit of variable, and these just the jump wires to make it all go. I think they're rated at 2 amps, or anyway, they're so cheap. If they blow, they blow. Yeah, these are voltage. You should set these up to a certain voltage, stop your steppers humming, which I did have one fail, so I'll have to redo that. And these are just the outputs to the stepper motors. So it's all very basic stuff. And then we have 2 Arduinos running the sliding fiddle yard. Now this one on the right gets the inputs from JMRI, CMRI, and there's 160 plus positions I can have on my layout. I'll show that in the next video. And I did have inputs outputs on this one, but the packets were crashing and no one seemed to know what to do, so all I done was added another one now. So this one is inputs only and will trigger output, not over the RS485 net, but just trigger this Arduino to send the signal back. So this is coming from JMRI, goes into the board, stepper motors, move to position 59, moves it. Once it's in position, this will then tell this Arduino to send back in position. It will take another command then. I will have to do the code because it is the schedule for it is the sliding fiddle yard sets itself to 0, so it goes to the right, bump, hits the end stop, it knows exactly where it is then. I send a command, move to track 60 or position 60. The sliding fiddle yard then will not take any more commands, or the Arduino won't take any more commands while it's moving. So it basically blocks it. Moves to the position. First of all, no, it actually checks if there is anything blocking the infrared detectors. If there is, it won't move. If there's something blocking it, it just sits there, does nothing. Till that is gone, and then you have to command it again, move to 60 once the obstruction's gone. I think that's how it works. And then once it gets there, it may have to change the track polarity. This is all set up in the Arduino sketch. And then it goes back and it tells JMRI in position, do what you will with the loco now. It's fairly just logical, I think. There's nothing else on there, just a different pitch. Right, this is going underneath the layout now. This is a PCA 9685 which controls all the little turntables and turnouts. Super little device, connect to all your servos up to it, 16 per board, piggyback boards, 1,000 I think you can turnouts you can get off one Arduino. This is a makeshift, these do my turntables. So input the SG servo from the PCA 9685, turns the servo. This servo is connected to his back gear. This one's connected to is a 5mm rod that goes in the middle of my turntables, and just turns it to where you want it. Now, big bolt there. I have learned that. Alright, I put 3mm bolt in there to start with. 3mm bolts just don't grip plastic unless you start putting threads in or inserts in. So 6mm bolt and a 5.5mm hole, screw it in and it's rock solid. You can't oh, you can over tighten it, but when you hit the bar, you know you're there. With a 3mm bolt I was trying and it was stripping out, so it looks a bit clunky, but it absolutely works fine. The turntables in the video, if you saw it, are going a bit fast, but in the sketch I can slow them down. That's all for testing. Similar thing for the turnouts. SG90 moves this bracket here, and there's another 5mm rod coming through from the turnout, just turns it. Arduino Nano, and this is a sensor one. So on the layer I've got embedded reed switches, encapsulated reed switches all over the layout. So it's a magnet job, magnets over the reed switch, triggers the Arduino, sends it back to JMRI. Thank you very much. There's another RS bus controller. Every Nano has a bus controller, and that's just the way it works. 2 wires, and that's all you need to join to the next one. These servos are for the canal layout. Now, in my wisdom, when I built this, laid the points on there, but they're a devil to get to now. So I've been very gentle with them, and this is a very flexible piece of wire. So when this turns, this will just move the points without giving it any stress. It will bend. It's a very flexible piece of wire, which is easily replaceable, because I don't want to damage the point blades, because they're a murder to get to. Another bad design. There we go. This is a picture from the underneath layout, the canal. You can see the canal track here. So it comes along the front here, and it loops round. So I have one loop this side, one loop that side, and they're connected. So got quite a few options to move trains around. As you can see, my wiring's not the greatest, but it's there. And and this is the video of actually working. Here comes the hand of God. Nope, it decides this is where I need to adjust the sliding fiddle yard. There's too much of a step on certain tracks. Because I stood it up in the corner, I think it's warped a little bit, so we need a bit of refining on there. But the accuracy of lining the tracks up is spot on. I wasn't going to pay hundreds of pounds for linear rails and stuff like that. This is all what I found in the garage, and it seems to work. Yeah, everyone's got a little step on it. And these are the little turntables. They're more for show than anything else. I can get a wagon and I can turn them round. In the first video, these were spinning round like crazy, but that's because I haven't set up the slow speed on them. If I set the slow speed up, it takes a long time to go through the sketch, and for testing wise, no, you just need to make it go to position. But you can see the accuracy is quite good for lining up the rails. It's just the height wise I think I've got to adjust quite a bit. I don't know if there's anything else on this, or it's just going through. No, it's just lining up the tracks. Let's say 2 years sat in the corner, I put it on and it worked, so that was quite surprising for me.